So next topic in module 1, part 2 is structured and unstructured control flow. So we have started with the control flow. Control flow means the order of execution in a program. So there are two types of control flow available. One is structured control flow and second one is unstructured control flow. So what do you mean by structured and unstructured? If you are using GOTO statements for the control flow, then that is unstructured control flow. And in the traditional programming, we have used if else, switch, for, while, functions, and recursion, etc. They are structured control flow. So when you're writing assembly code, sometimes we will use GOTO statement, right? That means we are just we are just representing the control flow of the program. From this point to next point, the control flow should go. That is the need of GOTO statement in the assembly code, right? But where we are not specifying conditions and all, just we are writing GOTO. So if you are writing GOTO in any language, then that is an example of unstructured control flow. But in the structured way of control flow means you are writing loops, that is iterations, or selection statements like if, else, switch, etc. Or if you are writing some functions, so if you are implementing function call, so that way of control flow is called structured control flow. Okay, so there are two types of control flow. So you can see here the example of unstructured control flow. Unstructured control flow means using GOTO, right? So you can see here you have used GOTO in the Fortran language. And here you have used jump. So jump is also an unstructured flow that is used in assembly language. So most of the cases, GOTO is an example. Then the most important topic, that is structured control flow. This is actually repeating university question from the first module. What are the 7 constructs for specifying the execution order? So these are the 7 different ways to implement structured control flow. Sequencing, selection, iteration, procedural abstraction, recursion, concurrency, and non-determinacy. So these are the 7 different ways to implement structured control flow in the programs. So the first one is sequencing. What do you mean by sequence? We know that we are writing program in block wise, right? So in the C programming and CPP programming, we will use this braces to represent block. In Pascal modular, you will use begin end to represent block. In the Python, we will use indentation to specify block. Ada, you will use declare begin end for the block representation. So if you are writing a block in your program, you have to execute the code of particular block in a sequential manner. That means from the starting to end. So if you are writing a block in your program, block of code in a program, you have to execute that block of code in a top-down order. That means from the first line to last line. So this is one of the way of control flow. That is called sequencing. So sequencing is similar. Sequencing is implemented in top-down order. So which is applicable in blocks of code. In different languages, blocks of code is representing in different way. So in a traditional programming language like C and CPP, we are representing block using parentheses, braces, right? Clear? So this is a one way of control flow, that is sequencing. Second one is selection. That is another way of control flow. So simply the selection method is implemented using if else or switch. So we know that if else, where we are selecting one condition, right? So if condition is true, then we will execute the statements which is under if. If condition is false, then we will execute whatever written inside the else component. So where we are selecting the set of code for the execution, or we are selecting the control flow of the program with the help of this condition written inside if. Okay, so the condition is always Boolean. That means condition is always output like true or false. And in the case of switch also, we will have different cases. So based on the conditions, we will choose any one of the case from the switch. So where also we are selecting the control flow of the program, or we are selecting the code of execution. So this selection is one method of structured control flow, and they are implemented using if, else, or switch. Clear? So this is the second way of control flow. And third one, of course, iteration. So iteration means we are repeating the execution of a code. A set of code that can repeat again and again. So that is a way of another control flow. That is iteration. So where also if one particular condition is true, then that set of code or set of lines will execute repeatedly up to a particular point. So that is a way of iteration, right? But there are three types of iteration is there. One is pre-test iteration. Second one is post-test iteration. And third one is mid-test iteration. So we know that entry control loop and exit control loop is there, right? So when you are studying while, where you are checking the condition at the start. That means before executing program, you are checking the condition. So that's why the while is called entry control loop. And in the case of do while, you are checking the condition after execution of first time, right? First time you are executing the code, then only you are checking the condition in the case of do while. So that do while is called exit control loop. So if you are testing the condition at the starting, then that is called pre-test loop. If you are testing the condition at the end of the loop, then it is called post-test loop. If you are testing the condition at the middle also, then it is called mid-test loop. Okay, clear? So iteration മൂന്ന് തരമുണ്ട്. Pre-test, post-test, mid-test. So നമ്മള് condition starting check ചെയ്യുന്നുവെങ്കിൽ, ഓരോ iteration starting check ചെയ്യുന്നുവെങ്കിൽ, that is pre-test iteration. നമ്മൾ ഓരോ iteration എൻഡിലാണ് ചെക്ക് ചെയ്യുന്നതെങ്കിൽ, that is post-test iteration. ഓരോ iteration in between നമുക്ക് ചെക്ക് ചെയ്യാനുള്ള possibility ഉണ്ടെങ്കിൽ that is mid test iteration. So here you can see the examples. When I am sharing the PPT, you can see these slides. I think you can check the mid test because mid test we didn't see till now. So you can see here, this is a way of mid test. Here you can see the example in ADA. Here the loop is started from here and 4 exit. Then you can see that at the middle also they are checking the condition. So this is an example of mid test loop. Then recursion. So before recursion, the fourth one here is procedural abstraction. So procedural abstraction means that is the representation of function simply. So what do you mean by subroutine? What do you mean by procedure? What do you mean by function? Is there any difference? Yes. So the procedure function are commonly called subroutines. And subroutines with return type is called subroutine which returns a value, then it is called function. Subroutine which do not return the value, then it is called procedure. Subroutine which returns the value, then it is called function. Subroutine which do not return the value is called procedure. So the function, procedure, that is also one way of structured control flow. And then recursion, you know that the function calls itself. Function calls itself, then it is called recursion, right? So here you have to study a most important topic, that is tail recursive function. You can see here, this is a recursive function. This is also recursive function. But here, in the after recursion, the +1 is also there. That means the returning, the recursive output, recursion output +1, right? So after recursion, there is an arithmetic operation also there. But here, the recursion output is returning. So there are no other operation after recursion. So if the recursion output is returning immediately, then it is called tail recursive. If the recursive output is returning immediately, then it is called tail recursive. If the recursion output is added with the value or it's subtracted with another value, then it is returning, then it is called non-tail recursive. So tail recursive function are functions in which no operation follow the recursive calls in the function. Thus, the function returns immediately after the recursive call. Clear? So tail recursive functions are functions in which no operations follow the recursive calls in the function. Thus, the function returns immediately after the recursive call. So you can see this example. This is a actually previous year university question in the case of tail recursion. So Fibonacci series. So here you can see this program. This is a program in C where we are implementing Fibonacci series without recursion. And these two examples are implemented using recursion. But here tail recursion is there and here non-tail. You can see here the tail recursion because there is no operation after recursive call. The recursive call is directly returned. There is no operation after recursive call. The recursive output is directly returned. But here the two recursive calls are added and the return. So after one recursive call, there is another operation is there. So this is non-tail recursive. non-tail recursive. Non-tail recursive. So this is tail recursive. So you will get a question like implement Fibonacci series without tail recursive or with tail recursive. So tail recursion means the recursive call is returning immediately without any other operation after that. That is tail recursion. If there is any operation after recursive call, then it is called non-tail recursive. So in the case of recursion, you have to remember this topic. This is very much important in the university exam. The last one. So we have studied sequencing, selection, iteration, functions, recursion. So now we are having no determinacy. That is another way of structured control flow. So you can see in this example, if A greater than B, max equal to A, else max equal to B. So this is a code of program to find the highest among two numbers. This is also the program to find the highest among two. But in the case of A greater than B, if A is greater than B, then max equal to A, else max equal to B. So if A equal to B, then which part will execute? Max B will execute, right? But if A equal to B, here what will execute? Max equal to A will execute. So output will not change, but the order of execution will change with the condition, right? With the condition, right? So the order of execution, order of control flow will change with the condition, but the output will not change. In the case of side effect, we have discussed the output is changing with the order of execution. But here, with the condition, depends on the condition, the output will not change, but the order of execution is changing. So this is non-determinacy. And here, this A greater than B, that's a condition, right? So that condition is called God. G-U-A-R-D. And after condition, there is a statement to execute. That is called guarded commands. So if condition statement list, that condition is called God and the statement list is called guarded commands. Okay, so the guarded command is actually a new term. So when you are writing if else, if there is a Boolean condition, then it is called God. After that, there is some statements to execute. That statements are called guarded commands. Clear? So these are about the structure, control flow, and unstructured control flow.